Students in the United States and Finland participating in a new project-based learning model are not only learning more, but becoming more engaged in class. Research from Michigan State University shows. Joseph Kraychek is Lappin Phillips Professor of Science Education with a faculty appointment in the MSU College of Education. He's the director of Create for STEM. That's a joint institute between the Colleges of Natural Science, Education, Engineering, and Lyman Briggs. Create's mission is to improve the teaching and learning of science and mathematics through innovation and research. He and his colleagues explain powerful early findings from their ongoing international experiment in a new book for educators, policymakers, and researchers. It's titled Learning Science, The Value of Crafting Engagement in Science Environments. And it's a pleasure to welcome Professor Kraychek to MSU Today. Joe, good to see you.
Thanks, Russ. It's a pleasure to be here and talking with you.
Can you first tell us a little bit more about Create for STEM and its mission? What do you do there?
Sure. Create for STEM, and it's an acronym. And so I'm going to spell out the acronym, and you have to follow along with the CREATE. So collaborative, research for education, assessment, and teaching environments. Create for STEM, science, technology, engineering, and mathematics. CREATE is a institute that actually is funded through the Provost Office, through the College of Natural Science, and the College of Education. And besides those two colleges being involved, the College of Engineering as well as Lyman Briggs are also part of what CREATE's all about. And the reason why it's this 4 colleges is because the mission of CREATE is to improve the teaching and learning of STEM, K through 16. And to do it through research. That's why it's collaborative research. And so we work together jointly, the faculty in those various colleges, to try to make a difference in how children learn. If it's K-12 or if it's in higher ed. We have some amazing efforts going on in our colleges of natural science and engineering and Lyman Briggs, really to try to improve the teaching of STEM. But we also have some wonderful K-12 project, which this conversation is about, to really improve what it's all about. Because I think you know that STEM is integral to our society.
Yeah.
We can't, you're listening to this on a podcast. These did not exist 10, 15 years ago, right?
Right.
How does that digital nature of these podcasts work? This is all STEM. And so science and technology and engineering drive our society. So if you don't even plan to go into STEM, you still have to understand what's going on. Maybe not understand how your podcast work, but certainly going to the doctor's office to understand, do I really need to get this flu shot? Are these organic eggs really that much better for me than these other eggs that aren't listed as organic? Those are all decisions that people in the public have to make. We also have to vote on important issues like water quality and air quality. And so these, even if you don't become a STEM person, these are really important. But you know, the employment that out there is right now is really in STEM as well. There's lots of employment, but you do, as a learner, as a person, as a human being, you do have to be prepared in order to take those jobs. So there's good jobs out there, but they're STEM related. But you don't have to be interested in STEM. STEM's still really important for your everyday life. And that's what Create's all about. It's through research or innovation, through trying to, and then not only just doing something, but then figuring out, does it really work in the classroom? Through investigations, we investigate, and then we try to inform the rest of the world about what we're doing. So that's what Create's all about. It's to improve the teaching and learning of STEM through innovation, investigation, and informing the public about what's going on.
And Joe, has the STEM curricula not been taught as well in the past, or because it's so becoming more and more important in our technology-based world, is STEM just more important, thus needs to be taught better?
You know, there's always been a chosen few in our society that like STEM, or they were driven externally to be going to STEM. But for the most part, come junior high, kids lose interest in STEM. And so the fallout as we get towards high school in chemistry and physics is just tremendous. Very few percentage of our kids have never taken physics. It's probably one of the lowest classes lowest enrollment that's out there. But it's so important for our world, right? Understanding energy, understanding forces, understanding how digital technology works. These are critical ideas within within physics, and very few people really understand energy, right? I mean, should we invest in our nation to build trains that run across our country? Is that really going to make a difference in air pollution? Or do we stick with our cars that are gas driven, right? What works better? That's a question that's rooted in physics. And do these trains that sort of float above the track, are they really that much better for us? I mean, I would argue yes, but those are decisions that every human being has to make. And it's related to understanding physics. And very few high school people go into physics. It's just not a area that's hardly motivated. A little bit more go into chemistry, but still, even in chemistry, we lose people going into that field. And so this project that I'm here to talk to you about today, with my good colleague here, Barbara Snyder, who's also in the College of Education with me. That project is all about how can we really craft engaging science environments really to promote students' learning in chemistry and physics. Interesting enough, this is a joint project between the U.S. and the Finnish government. Now, I think many of you may have heard about Finland and how they score really high on international science tests, PISA, for instance. And this is true. They do really well. Interesting enough, they do extremely poorly when it comes to kids' motivation to continue to want to learn science. And that's why we're joining efforts, right? So their nation, and you have to realize Finland, it's actually bigger than the state of Michigan size-wise, area-wise, but population-wise, we're pretty similar. And you have to stop and think, if you have a society that has a population about the size of Michigan, and you decide your children aren't interested in going into science, who's going to run your society? Yeah. Right? You do need people to run your society. So Finland is really concerned with really having talented children who really want to continue to go on in science. And so they were worried. And so we joined forces with Finland to try to figure out, how do you really support kids and getting really interesting, bringing that wonderment back into learning science, really wanting to do it. Because if you don't have that wonderment, if you don't have that drive, you are not going to spend the time trying to figure out what's going on, because they are challenging. I'm not going to deny it, right? Learning chemistry, talking about the things that are going on in the micro world, understanding all the complexities of energy transfer. Those are challenging ideas, right? It takes intellectual effort, and you're not going to spend that intellectual effort unless you yourself are really motivated to do it. So the challenge that my colleague Barbara Snyder and my two really good colleagues in Finland, Jari and Katarina, took up is, how do we create challenging learning environments to really support kids in learning the big ideas and the practices of science? That's what this project was all about.
And Joe, what is next generation science standards, and how does that fit into the research?
Sure. So about in it came out in 2010, our nation underwent an effort to try to really think deeply about what it is that all kids really have to know K through 12 in science education. And when I say our nation, it wasn't funded by the federal government. This is not a federal government concern. This is actually funded by the Carnegie Foundation through the National Research Council, which basically often holds sessions where they bring together scientists, policy people, the public, to delve deeply into issues. And so they had one of these studies to try to figure out, what is it that every kid in our nation should know and be able to do. A book was released called the consensus book was released called The Framework for K-12 Science Education. And I say it's a consensus document because the document that was produced was sent out to various organizations like the National Science Teachers Association, the Physics Association, the Biological Association, to different state governments for them to get their approval of this work. But the important thing is that the National Academy of Science also gave its stamp of improvement. And now, if you know anything about being a scientist, to be in the National Academy is quite an honor. And so these are the people who are in our nation making a big difference in science. And so they said, yes, the stuff that's in here is what all children need to learn by the time they end 12th grade. So given that and I was fortunate actually enough to be on the committee that wrote, what are the big ideas that are supposed to be, that all kids in physical science should really know? I was actually the chair of that committee. My background is actually in physical science. And given that document, so they came up with what were the big ideas in physics, physical science, biological sciences, earth and space sciences, and engineering. Plus, what is it that scientists do, right? The practices of science. So that document was then used to create what was called the next generation of science standards. And what that committee did, which I was again fortunate to serve on, was to say, look at, and this was based on the recommendation that came from the framework for K-12 science education. It said that standards have to be phrased in a way that kids use their knowledge. And so we have a totally brand new set of standards that are an integration of a scientific practice and the big ideas of science, plus these ideas called cross-cutting concepts that sort of cut across various disciplines about kids actually being able to use their knowledge. So it's not just that kids will understand the particle nature of matter, but kids will be able to construct a model to show that when matter changes, it undergoes some kind of change at the structure at the molecular level, right? It's a totally different type of standard. And our nation right now is involved in an effort to try to figure out various states. Many states across our nation either adopted or adapted them. I don't have the exact numbers. And not all states have, but a fairly large number. So states in our nation, and Michigan was one of them, by the way, that adopted them, are trying to figure out what does this look like in the classroom, right? So when you have a standards that says kids will develop an evidence-based explanation to show how human impact has influenced climate, right? What does that kind of look like in the classroom, right? It's a very different kind of standard than we had in the past. And so researchers and our federal government now is involved in saying, what does this look like? If these are standards that the nations are adopting or adapting, what does it look like in the classroom? What should we do? And so that's why we got this particular grant with the Finns to try to figure out how do you create these kind of engaging environments. And we take as our starting point that kids have to be able to meet the next generation of science standards. Finland has a very comparable set, right? So we call our standards performance expectations because kids are supposed to be able to do something with the science ideas. The Finn call these things competencies. But both nations, and the big ideas, of course, the big ideas of science don't change if you're in Finland or if you're in the United States. So they're very similar, right? Our focus on energy, our focus on the particle nature of matter, our focus on evolution and genetics and gene environment interaction. Those are consistent across the two nations. So it's been an interesting effort to work with them these last 6 years.
And Joe, you've touched on it throughout our conversation, but a little bit more about why is the STEM education so important? Why do we need to get more kids excited about it? And some people add the A for STEAM. The A is for arts. Are you an advocate of that as well?
Once again, I think for citizenship, we all have to understand STEM, right? A lot of the genetic engineering stuff is really pertinent to people's lives, right? The genetic engineering of food. Should I get a vaccination or not? Should I vaccinate my child? Do we really have climate change, or is this just a little blip that always happens, right? These are all ideas that no matter what field you're in, understanding them are critical, right? Yeah. What does it mean to live in this society and make a judgment? And also understand that science is not just something that someone made up, right? People have a fundamental misunderstanding of what we mean by theory. They think, oh, it's someone's idea. No, that's not true in science, right? In science, the theories that we have are supported by evidence. Now, they change as we get more evidence, but the fact is, the ideas that we use in science are soundly supported by the evidence we have to that date. And that's why we've been able to make such great progress throughout our nation and the world about, health, medicine in general. Look at the buildings we can build nowadays, the wonderful bridges. Those are all a result of constantly getting more new ideas about how science works. The digital technology has just exploded, right? Can you imagine carrying all these songs around and these little tiny things in our back pockets? Right? It didn't exist 10 years ago, right? So this is all science that's related to everybody's life. But we also need scientists, people who are trained in STEM, to do a lot of wonderful technology jobs and create the new technology, right? So it's both, we need people power to drive the technology. You're not going to walk in and work on an assembly line anymore because we got robots doing that technology. But the robot breaks down, someone's got to fix it. That's a technician. And you're not going to fix the robot unless you have a lot of science training. When I was a kid, I could take a car apart all the time.
Yeah.
Nowadays, right, it's impossible, right? The technology that's in a car, right, is impossible. So you have to know some things about, if you're even going to be in the work of the car industry and as a mechanic, you have to understand technology and how things work. So it's fundamental, both as a citizen, to get good jobs and also to create new products and new innovations in our world. So at all levels, I think STEM education is really critical. As I'll have to tell you, I am a science educator. I've been a science educator my whole life. I started off teaching high school chemistry for a number of years. I first heard of STEAM when I was in South Korea. I had a sabbatical in South Korea. And to this day, I'm still trying to figure out what that A means. I think we're getting, some people want to say it's art. Some people want to relate it to design. Certainly design is really important in engineering and in science. You have designing stuff all the time. And I love art. So I'm not exactly sure what it's unclear in the field, at least from my perspective of what it means. So.
And we've been talking about it throughout the conversation, Joe, again, but more of what you're finding in your research and what's next. What do you want to pursue next?
Sure. So the work that Barbara and I, along with Yari and Katerina, and I have to mention that we couldn't do all this work if it wasn't also for all the very talented postdocs and graduate students that work with us, right? So I've been using Barbara and Katerina and Yari's name, but I have to tell you, without some of the brilliant postdocs that we have with us and their commitment and the graduate students' commitments to really want to make a difference, we would never be able to have this, right? So I did want to bring that out to sort of see how important they are. So what we're doing is what we're really trying to do is how do you create these engaging learning environments? And we've actually, we took a perspective of trying to use what we call project-based learning, which really engages kids in instruction by answering questions that are anchored in phenomena that kids might find interesting. Certainly not maybe as dull as you might have gone into something that's more motivating than what's there in the past. I'll give you one example, for instance, and I'll do it because I'm a chemist. In chemistry classes, if it's high school or if it's college, you're always studying the periodic table. But that's what you're doing. We're going to study the trends in the periodic table. Well, that's motivating, right? Now, if you're a geek like me, if you like chemistry, you might find that interesting. But most high school students say, okay, the periodic table, I think it's something they have to memorize. I never memorized the periodic table. I learned it by using it. And so that's one of our approaches, by the way, using ideas, not just memorizing ideas, but using the ideas. But instead of saying to children, we're going to study the periodic table, what we do is we pose them a question. You eat table salt every day, isn't it?
Yeah.
True? Right?
Right.
We sprinkle it on our food. It really is a wonderful enhancer of flavor, right? No problem. But it's made up of these two things, sodium and chlorine. I don't know if you know anything about chlorine, but you take a little tiny piece of sodium. You take a little piece of sodium, you drop it in water, it explodes, right? Chlorine, that we don't want to be around it because it causes us to it's like a burn. It reacts with our skin and everything, right? So you take something harmless that actually enhances the flavor of food, and it's made up of these two reactants, sodium, which is explosive, and chlorine, which is deadly to us. How come? How come you can take something like sodium and chlorine, they can react together or mix together, or actually react together and form something that's harmless? So so instead of driving a unit by the period, we're going to learn about the periodic table. We'll say, we're going to figure out why sodium chloride is safe to eat and sodium and chlorine are not. So all our projects, remember I said we're involved in project-based learning, are driven by both a scenario and kids experiencing these phenomena. It's very simple. You have a little plate of sodium and sodium chloride. Kids can taste it. They know what it tastes like. And then the teacher demonstrates what happens when I take a piece of sodium and I throw it in water. Well, kids love it because it explodes and fizzes around and bursts into flame. And so this is sort of our catcher to say, okay, why is that? Why can you eat sodium chloride, but you can't eat sodium? What's going on here? And so that's some of the work that we do. This past year, last academic year, 2018, 2019, we did a relatively large, what's called an efficacy study. And what that means is that we actually had students who were involved in using our materials in chemistry and in physics. And we worked very closely with the teachers, right? You can't just hand these new materials off to teachers and expect for them to really understand. It's different. It's different than the way I was taught. It's different than the way they were taught. And so we do long-term professional learning to support the teachers in actually doing this kind of work. So we took our treatment group, which were our teachers who had this professional learning and who also have the materials, and kids have the materials, and we compared them on a summative assessment with control kids who also have the same subject matter, right? It's not like the kids did not study the periodic table or they did not study forces and energy. They studied the same topics. And we gave them a summative assessment that was developed by a third party, actually the Michigan Department of Education, in preparation for the new Michigan science test. And kids in the treatment group outperformed significantly and substantially kids in the control group. Now, that's an amazing finding, and it's also an amazing finding that we sort of parsed out the group based upon a pretest. So we had kids who were sort of in a lower third, middle third, and high third. And no matter what third we looked at, the kids in the project-based learning outperformed the kids in the kids in the control substantially and significantly. Now, this is a big deal. Why? Because kids typically who go in the chemistry or physics are kind of at the top of the cream already, right? I mean, there's a filter there. So even though we have this filter and we matched the kids so that there were, the treatment group was not biased to having more motivated, higher intellectually driven kids, they were matched. The kids in the treatment group outperformed the kids with the PBL, outperformed the kids in the control group. Interesting enough, Finland did a similar kind of experiment, and they have very similar results that we do. Quite an amazing finding, not only for what should happen in our schools in the United States in chemistry and physics, and I would generalize to all sciences, but also what should happen across the world, like in Finland and stuff.
Yeah. Well, Joe, the book that's chronicling some of the early findings in your research is called Learning Science, The Value of Crafting Engagement in Science Environments. Summarize for us the key takeaways from that book you'd like us to get.
Sure. In that book, we talk about our treatment, which is project-based learning, and we try to support teacher leaders or policymakers in what that actually means. What does it mean to engage kids in project-based learning? And we have a fairly robust theory about it. I already explained one of them about trying to come up with interesting scenarios and phenomena that can actually drive student learning. But we also talk about other features like the importance of really getting kids engaged in investigation and using evidence to support their claims, because that's an important part of what it means to be science. We also, in that book, talk about the importance of teachers trying to support kids working together to sort of make sense, right? How do we get you and others in the class to dialogue with each other about what does this mean, right? What does this data mean, and to try to make sense of it. So we explain our theory of project-based learning. We also provide some really strong data about how it really motivates children, particularly supporting their imagination and their social emotional learning about engaging in these kind of efforts in chemistry and in physics classroom. Unfortunately, the book was published before the beautiful results of the efficacy study came out. I guess that means we have to write another book.
There you go.
But the book does talk substantially about how it really engages high school kids in chemistry and physics, and really wanted to get engaged. We provide example lessons of how we did this work. We have quotes from teachers about the value of this product. So that's what that book is all about. You know, the United States is extremely diverse, right?
Yes.
We extremely diverse, and we are a society that is made up of diversity, and we celebrate our diversity. And so Barbara and I are working at trying to get all kids, all children, all high school learners really engaged in the learning of science. So we work in urban areas, we work in rural areas, we work in suburban areas, because we're really concerned about all children really being able to learn. And in fact, our work isn't only here in Michigan. We work in Detroit, we work in Grand Rapids, we work in Central Michigan. So we're through the state with our work here, but we're also in California because it's such a different population. So we're in Los Angeles public schools as well as southern San Diego. And interesting enough, these materials work across these children who have different backgrounds, right? If you're from a Latino family, from in Southern California, you have a very different background than if you're coming from rural Michigan. And so these materials our results indicate that kids are both driven to learn more, as well as the efficacy study shows that kids are able in all these various environments really to learn more. So we're really excited about that. It's a really important part of our work to really try to support all children in learning, because if we're really going to have a just society, we can't have those who learn and those who don't learn. We have to make sure everybody is learning, because otherwise we're really saying you can have the jobs in technology and you can't. So our focus is really on supporting all learners and really trying to develop usable knowledge of science, either if it's for their own everyday life or if they plan to go into a career in science.
Well, Joe, thank you for telling us about your important research here on MSU Today.
Thank you, Russ. It's a pleasure being here and talking about this important work and chatting and meeting you.
That was Joseph Kraychek. He's the Lappin Phillips Professor of Science Education with a faculty appointment in the MSU College of Education. He's the director of Create for STEM, which we've been discussing. That's a joint institute between the Colleges of Natural Science, Education, Engineering, and Lyman Briggs. Create's mission is to improve the teaching and learning of science and mathematics through innovation and research. More on the web at createforstem.msu.edu. That's the word create, the number 4, and then STEM, STEM, createforstem.msu.edu. And I'm Russ White. This is MSU Today.